We're live. Brian, welcome to the first ever SOSE podcast on systems engineering, in particular architecting systems. Welcome to the show, or whatever it is going to be called. Do you want to start off by telling us a little bit about yourself and your kind of background in systems engineering?
Absolutely. Yeah. Thanks for having me, Connor. I really appreciate it. It's a great opportunity to talk and discuss systems engineering with other people. So great to be here. I'm Brian Moberley. I'm currently living in the United States in Huntsville, Alabama. I'm working for a company called Strategic Technology Consulting. It is now an Arcfield company. Our company was purchased by a larger organization a few months back. So now we're umbrellaed under them. And we have the opportunity to do a lot of model-based systems engineering on a day-to-day basis for all types of companies, all types of projects, whether that be commercial projects or Department of Defense projects. I personally like to do a lot with modeling and simulation involving Cameo Systems Modeler, but I've been dealing with MBSC for the last 5 years, and I really enjoy it. It's one of the most interesting and fun things you can get into because there's so many rabbit holes you can go down, and there's always something new to learn. So happy to be here and glad to be talking with you about this awesome topic.
Yeah, that's really cool. So how did you first get started in system engineering and then moving into the MBSE domain?
Yeah, that's a great question. My first systems engineering job was actually out in Simi Valley, California, working for AeroVironment. And I had a background in the Air Force that brought me into that position because I was a munitions guy in the Air Force. So I dealt with bombs, rockets, missiles a lot, and they were looking for someone with an explosives background. So that's how I got into that position and somewhat learned systems engineering on the job from a few veteran systems engineers who had been doing systems engineering for 30 years. And that was fantastic because I got to learn a lot about what systems engineering was and all different facets of that. But as we got into that, one of the things that I ended up doing was taking a course through MIT online, and that was the Architecture and Systems Engineering course. And that's how I found out about MBSE, and I wanted to get into that a little bit more. And that actually brought me out to Huntsville, where I started working under a Boeing contract at the time doing MBSE. So from there, it's just been Cameo every day and learning more and more and more.
Yeah. Wow, that's pretty cool. So you were actually part of the armed forces and then you transitioned. So how did you transition? That's just something that I actually get asked quite a lot about, is how do you transition from armed forces across into systems engineering? Is that difficult, or what sort of route did you take?
I actually, yeah, it's not as difficult as you would think. I would say, the one thing that's nice about being in the armed forces is you get a clearance. So having a clearance is very valuable, especially on DoD projects. A lot of times you'll end up, working on projects where they need you to be in a classified laboratory. So that's one of the nice things about having that background in the military, is it can give you that clearance and you kind of have a leg up in that sense. And then as far as the education goes, of course, while I was in the Air Force, I was going to school to be a commercial pilot, actually. And unfortunately, at the time, the economy turned south, and I ended up in Afghanistan working on aerostats. So I had actually worked with the British infantry over in Afghanistan around 2010. So all that together gave me a lot of various experience. It all kind of culminated and worked well with systems engineering because it's such an eclectic field of different things that you'll run into. So
yeah, and I can imagine that your background in using those systems in service and maybe in the maintenance domain as well gives you a really good understanding for when you actually come around to architecting systems, right?
Absolutely, it sure does. Yeah, you get to do a lot of troubleshooting out in Afghanistan, so you learn a lot about how things could be better, and that's what systems engineering is all about. It's about how can we make things better.
That's really cool. Okay, so coming on to architecting then. So in your eyes, what does architecting systems mean or look like? Or tell us a little bit more about that.
Yeah, that's a great question. I believe architecting is about putting together a design that can work well for the user and the stakeholders involved that have a specific need. Some people refer to that as bespoke modeling, where you're doing something for a specific purpose, and you're saying, we're making this design and it is specific for this user, for this need, for this environment. It's all very specific. So that's what an architecture really is good for, is putting together all the parts and pieces necessary to then meet that user intent. And that's where it comes in very handy to start with the user and those use cases and delve into what they want to do with the system, how they want to interact with that system, and then what are the parts and pieces that will enable that to happen. And that's where you end up with a logical architecture that can be that more flexible intermediary architecture that is supposed to not have those specific parts and pieces selected, but say what they're intended to do, how they're intended to fit together. And then those physical architectures can then say, these are the actual parts and pieces that we've selected for this iteration, for this system, and it should still meet those needs. And then if at any point in time you got to the point where you wanted to maybe make an upgrade to a system part, you could then go back and say, well, does it meet that logical architecture? And that logical architecture should be there to answer that question for you.
Yeah, I like that. So at what point does it really move away from the logical architecture into the physical? Does that kind of get parked, the logical one, and then gradually move across into the physical one, or do they coexist at the same time?
I believe they absolutely coexist. And a lot of times you'll see allocations from logical to physical architectures, and it's really going from abstract to concrete. And I think a lot of times people do think that there's one absolute logical architecture at one level of abstraction and one absolute level of physical abstraction. But I think there are actually more levels of architecture that can be in between there. And it's really a matter of moving from abstract to concrete. So a lot of times, even with a logical element, that logical element could be more abstract, or maybe it could be more concrete and still be considered logical. So that is an important thing to keep in mind, because I think a lot of people, they have a hard time selecting logical architecture components because they say, well, what level of abstraction really should it be at? And that's a great question to ask, but you also want to keep in mind that you're never locked in. Right? Even if you do select something, it's very iterative. You can always come back and say, well, we want this to be a little bit more concrete for this part of the architecture. And maybe if we need to abstract it up a little bit, we can do that. And then we can always generalize and use specializations, a lot of these little techniques that come in to then say how we can group things according to their common properties and maybe make things that are really abstract, but have these common set of properties. And then you can take it to the more concrete and say, as we move towards a very specific solution, these are the absolute properties that we have for this solution. And that's really what a physical architecture is. It says we've selected this, and this is what we're going with. Yeah.
And do you use any particular tools or methods to get you to the right level of abstraction? How do you know the right level of abstraction for your system is kind of met, that you can then say, okay, that's good, and then we're going to park and move on to the physical representation?
Right. That's, I believe, where a lot of the art of it can come in.
Yeah.
But if you do start with those use cases, I think you don't want to ignore what you have in your use cases and how they are specified, because some people will write these use cases and then they'll just kind of make this disjointed, disconnected logical architecture. And then they try to figure out, well, how do we connect these dots, right? And I think if you do start with those use cases, what you'll find is you have a lot of nouns throughout your use cases that'll say, I would like to open the car door with my key fob, right? Yeah. So if that was a use case, you've now identified a key fob, and that is actually something that can be put into your logical architecture. And so in that sense, a key fob would be the appropriate level of abstraction, and that can then become one of those logical architecture pieces. And then you can delve into a specific key fob for that physical architecture that actually shows this is the one we're really doing, but all of the functionality of that can be compartmentalized in the logical architecture. However, it all started with that use case and how you identified the need for it. So, yeah.
And then are you deriving requirements from the use case and then mapping those requirements across into the logical architecture to then say that traceability is going all the way through and kind of accounted for?
Absolutely, absolutely. So you may have a lot of times people will give you a set of functional requirements possibly, but then as you do move into those use cases, they can refine those functional requirements, and then you can extract more functional requirements from those, and then all of that can be traced together. So if you look at the OSM process, or object-oriented systems engineering methodology, you'll see that there are various ways to connect those dots. So every methodology will have some specific relationship types that you can use. And that's where the meta models come in handy to say, in our model, we'd like to use a refine relationship that says a use case can refine a functional requirement. But then you can also get into various aspects of validation rules and how those play into your actual model. But all of that can be very helpful in making a cohesive model and making sure everyone stays consistent across that project. So yeah.
Okay. Coming up a level then. Let's talk about the difference between document-based architecting and MBSE. Tell us a little bit more about why we've transitioned away from document, or why we're trying to at least, and what are the pros and cons of each.
Well, that's a great question. And that's really what brought me to MBSC. Is I was doing document-centric systems engineering when I first started, and I saw all the headaches, and as a systems engineer, you don't want to be dealing with documents and formatting tables all day long. And then when a requirements verification trace matrix needs to be updated, you're literally going in and manually creating links in a Word document to try to synchronize all of that. And then when someone says it's time to do a review, then you end up with 15 versions of a document with comments all over it, and no one knows what is absolutely true, what is current, what is old, what is the real document. So that's where the idea of the source of truth or authoritative source of truth comes in, because granted, a document can be an authoritative source of truth, but it doesn't mold very well with change. It doesn't keep up with change very well, right? So anytime you're making changes, you have to be very cognizant of what is the most current version of things. And that can be a big headache, and it takes a lot of time, a lot of effort to keep track of. And with MBSC, on the other hand, you can have one model that would possibly be stored in something such as a Teamwork Cloud, if we're talking about Collaborator or Cameo Systems Modeler. And then what's neat about that is that always has a version control on it. So it always has the most up-to-date model. That's where it is now. And everyone knows that's the current sheet of music that we're reading off of. So that's the big advantage of using MBSE, is everyone is staying up to date on what is current. And of course, when you do make changes, if you've defined things in your model, those changes can propagate throughout your model very easily. So if you make a change to requirement, well, guess what? The table in there has updated itself automatically. So that's very nice.
Yeah. And so referring to the three pillars of MBSC, then, we've got our methodology, and we have our language, and then obviously the tool as the third pillar. So what are the nuances, and what are the benefits of using one particular method over the other? You mentioned USEM, and you're I guess you're using Sysml, right? So that's one format. There's the Arcadia and all that sort of stuff out there as well. Is there any particular benefits of using one over the other, or have you had experience of any particular differences of each?
I have. I've seen differences with those, and one of the things that people like about USEM in particular is the fact that it is intended to be more object oriented, and then that brings in the concepts of object oriented, such as having the ability to inherit properties from other blocks using generalizations, and those aspects of things that become very useful in a model. They're such as, if you're using things such as Arcadia, there's a little bit different approach, and I don't have as much depth of knowledge in Arcadia, but I'm pretty sure that they don't have the idea of polymorphism involved, which is one of the object-oriented principles. So there are other aspects of having things object-oriented that becomes advantageous for things such as systems engineering, because they're easy to update, they're easy to change, and you can take advantage of, especially of the inheritance of other properties from blocks. So that's one of the nice things about that. But
similar to yourself, I'm more of an USEM man as opposed to an Arcadia. So I was trying to glean some information out of you, Brian, based on Arcadia, but we'll have to get an Arcadia expert in stuff.
Yeah, sure. It'd be good to hear from them for sure.
Okay, so we understand why we need MBSE as opposed to a document-based approach. We understand, the kind of three pillars that we need to kind of choose a tool, choose a method, and choose a language. What actually makes a good architecture? So you spoke a little bit about, the logical representation and the physical. What is some of the, baseline things we need for a good architecture of a system?
Sure. So obviously you have these various tiers throughout an architecture, and you want to have some high level context And I think some people get hung up on what that highest level block should be named. So I would not get hung up on that. For one thing, you need to have some block that just kind of encapsulates all of that. And then one of the things that it should encapsulate is the environment next to that system of interest. And as long as you have those two parts together, where you have this high level block that encapsulates an environment and a system of interest, and then all of those stakeholders around that, you can then trickle down from there and everything will be there. So as long as you're encapsulating all that in something, then you're off to a good start. So that's the first thing. As I said, some people will get hung up on whether or not you should call that a system context or a domain. And I wouldn't let that bother you too much, because really the idea is we want to pull together an environment and a system, but we need something to tie them together. And that's that highest level block. So if you call that context 1, or you could call it operational context, anything like that will work. And then as far as how that trickles down into a good architecture, it's really a matter of, do we have all the pieces involved that will help us meet that user intent? And over the last year or so, I've worked with someone who I'm actually contributing to a book with named Doug Rosenberg. And I've been working with Tim Wilkins as well on this. And it's going to be published this year about using AI in MBSE. But one of the interesting concepts is that really that those use cases can be that foundation for that solid logical architecture. And the way that you do that is by extracting the nouns out of those use cases. So that can start to formulate that solid foundation for that logical architecture. And then as you pull all those together, you may identify that there needs to be some other logical pieces involved as well. And then they can be inserted into that architecture. So of course, it's an iterative process. You don't ever want to say, hey, first pass and we're done, because it needs to be reviewed. A lot of people have opinions. You're always going to go back and change things. But that will start to pull it together. And as you iterate, you'll start to see that it has all the pieces that you need.
Yeah, I love that. Yeah, let's park the AI in architecture, because I want to come back to that. Yeah. I particularly resonated with what you spoke about, how capturing the environment and the key stakeholders there, because it's something that we often forget about, is we're so focused on just jumping in and creating some block definition diagrams to make a really good architecture. We forget about the environment and how it ties into our system of interest, right?
Right. Of course.
Yeah. Okay, so we've got some good architecture. So what are some of the key principles that, if you're new to architecting in MBSE, what are some of the key principles that you should be trying to adhere to? Or, is there a good architecture writing guide out there or anything?
There are a few. The names they're leaving my mind at the moment. There's a few new books out there these days that are pretty good for our architecting systems. I just forgot your question.
Don't worry, we can link them below somewhere. Don't worry. Yeah. So principles. So what are some of the key principles that you should be focusing on if you're relatively new to MBSE? You've just done some training. How do you get stuck in? What are some of the key principles to kind of focus on and use?
Right. Great question. Sorry. So key principles. I'm not sure if you've seen the last video I put out that had to do with 2 types of functional decomposition, but that is one of the ideas that I think can get a lot of people confused. So if you understand that a system function needs to be observable and verifiable at the level of the architecture it's assigned to, you'll be off to a great start. So that is a key principle right there. And I think that is one of the problems that people do run into, is they'll start delving into these deep trees of functional decomposition, not having any clue what part of the architecture they will be assigned to, or what will be performing those types of functions. So then they'll go in and they'll make another call behavior action that delves in even deeper. And maybe that has some pins that go out to some other output. And then what they'll do is they'll start putting in swim lanes, and then they have these really convoluted functional decompositions that are very hard to maintain. So if you can keep track of the level of architecture that you're at with a specific function, you'll be off to a whole lot better start. So that is one of those key principles I would say to pay attention to, is what level of the architecture will this function actually be allocated to, and can it be observed and verified at that level?
That's really
Like,
interesting. It sounds like you can almost architect your way into a corner that you kind of get stuck down then. So,
you
so
absolutely
how do you stop? How do you know, okay, enough's enough. I'm at a lowest level of abstraction that I need.
right.
What are some of the signs you should be looking for that says, enough is enough. Stop architecting.
Right. That's a fantastic question. And that's one that every modeler will run into is, when do we stop decomposing a function? And I believe the answer to that is when you say, hey, we're not going to be making this part anymore. We're going to be giving it to some vendor to create. And what they need is a specification for what it should do. And at that point, you do not want to decompose that anymore. If it's up to you to design that part, you may start delving into that a bit more. But if it's up to someone else, to a vendor, then you absolutely do not want to keep going. You want to stop there and say, this has been decomposed to that level that is good enough. We're going to then create a specification for that block and let someone else determine what the parts are, because that's up to them to create. So that's how if you fall back on that, you'll absolutely be off on a great start, because I have seen those cases where they just keep going, and you can end up at the atomic level where you say, now we have these two atoms that are interacting to do this function. And no one, you're never going to need to go that low unless you're a scientist, possibly. But yeah, that's a good rule of thumb, is if we can hand this part off to someone else, then we should not have decomposed that.
Yeah, that's a really good, nice way of capturing that. Actually, is stop when you have to give it to someone else, or that you're going to buy in the part type thing, isn't it? It's
Exactly.
like, that's
Exactly.
really nice.
Yep.
And okay, so what sort of mistakes do you commonly see in junior modelers, or when you're a chief systems engineer, right,
Right.
of model based aspects? So what are some of the key mistakes that you're seeing in junior modeling and sort of stuff?
Yeah, that's a great question. Of course, there comes in a lot with the tool that you're using, and a lot of tools, they all have their nuances. So one of those I was looking at the other day, reviewing a model. This is a very simple example. Someone brought in an accept event action, and it had a parameter, or it had an attribute. The signal did. So when they dragged the signal onto that, nothing happened because there's a cameo nuance where, unless you set a property to is unmarshal true and then drop your signal onto that, you won't actually see an output parameter or output pin come out of that. And what ended up happening was there was a result pin, and they didn't key into the fact that that was a problem, because it wasn't actually showing the output of that signal. It was showing something else, right? But unless you've worked with that a lot, you may not even pay attention to that, right? So there's a lot of little nuances that you'll run into with tools, but that can definitely, that all comes with practice. And I believe Cameo specifically is a tool that you have to practice, and you can get rusty with it if you haven't done certain things in a while. Let's say you haven't done meta chains in a while and queried your model in a while. There's a lot of little things that do take practice. So it's one of those things you have to be doing a lot to stay up with. But then as far as methodology is concerned, of course, that becomes one of those things where junior modelers can struggle if they're not familiar with, where are we in this process? What should we be doing now? And that's where I think a solid methodology can help a whole lot, to say, hey, we're on this step. Here's what we should be doing at this time. And USUM, it does have a good high level idea of what you can be doing or what you should be doing, but there are also parts where USUM leaves you hanging a little bit. And there's some things that could be refined more in that methodology to make it more clear to junior modelers what we should be doing, right? So one of those ideas is defining the mission requirements. If you look in USUM, it says, define the mission requirements, but that's about all it says, right? It doesn't really tell you much more about how do you do that? What should you be looking for, and those types of things. So that's where practice can come in, and also talking to more senior engineers who have experience with those types of things come in, and then refining the methodology more than you see even in the books. So I think if you can refine a methodology, you'll be helping the junior engineers quite a bit.
That's really good. And so we're moving into this domain of everyone starting to adopt MBSE, right?
Right.
How can a company, or how can a systems engineer push and drive the change towards a model-based approach in their company if they were typically a document-based company?
How can a junior engineer push for that?
Yeah, a junior or even a systems engineer that realizes the benefits of MBSC and wants their company to start moving towards an MBSC approach.
Right.
What are some of the tips and tricks that they can start nudging their company in that sort of direction and start building the business case for model-based system engineering as part of the process?
Right. So that's a great question. I believe that's one of those cultural issues, right? Where sometimes people who've been doing things a certain way, they don't necessarily want to change. They've gotten comfortable with where they're at and how things are going. So in some senses, and in some cases, I believe the best thing to do is actually go somewhere else. That's my
Okay.
honest advice.
Yeah.
Now,
Yeah.
and then in other cases, if you do believe people in management are open to that, then they can start making the case and say, hey, look, if we try this on a small project, let's start building on that. So that's absolutely the best path to go, is if you can start adopting that on a very small project, not something where you're getting 15 engineers involved, because that becomes a disaster very, very quickly. I've seen that as well, where MBSC gets thrusted on a large project, and then a whole lot of new people are all learning together on that project, and that is a disaster, because you end up with a terrible, terrible model, and everyone's confused. No one really knows what is happening. So if you take the let's gradually bring this in approach, that'll be a much better way to do that. So think on small projects. How can we get our foot in the door? And there are some tools out there, obviously, that are a lot cheaper. So that would probably be a good place to start, is a cheaper tool. That way the company isn't being hit with that sticker shock of, wow, this is very expensive, and now we don't know what to do with it, right? So, it's great to start small and then work from there. Yeah.
That has to be the two biggest blockers in MBSE, right? Is the upskilling aspect of actually
Right.
not a lot of people or engineering teams fully understand and they're trained in MBSE
Right.
or in SysML, right? Is what we're talking about, and then the new SEM and actually modeling. And then the tools, right? It's actually you need investment for a good tool or a bad tool, and the investment for training. It can be
Right.
quite difficult to drive that change, kind of.
That it is difficult. It's very difficult. It can be done, but you have to have managers who are open to that. So as long as you have open-minded managers who can see that there could be value in that, then you're off on your way. But there are some cases where that's not the case. And that's when it's best to run somewhere else.
Yeah, no, I think your advice is spot on. Actually, start small, start with a small pilot project. Actually start implementing and actually demonstrating the value that you can, produce on a small pilot project by following a model-based approach, and actually, sort of start building that business case and gradually bringing people on board along the way. It's not going to happen overnight, and yeah, it's
That's
okay.
100% the truth. Yep.
Yeah. So moving on then. Okay, so how do people go about actually learning model-based system engineering? There's certifications out there. Is there any that you particularly recommend? The OMG stuff is out there.
Yeah. So OMG, I don't want to talk poorly about OMG. The only issue I have with OMG currently is if you were to take the certifications such as the OCSMP, they're currently based on very old versions of SysML, right? So if I were to go take the OCSMP level 1 test right now, they would have questions about SysML version 1.2 in there. And we're already up to 1.6 and then a beta version of 1.7. And now we're knocking on the door of SysML version 2.
Yeah.
So the question becomes, is that necessary to have a certification in a language that is really not even used that much anymore? Possibly, if you like that type of thing. But I haven't pursued that certification because of that reason, because it seems very out of date. But as far as other ones that are good, yes, there are other good trainings out there. Of course, if you do take Lenny Delegati's training, he has the OCSMP Accelerator course, which is actually a very good course. He delves into SysML. Of course, that is meant to prep you for that OCSMP test.
Yeah.
But you're going to learn so much about SysML that is still applicable that it'd be very good to take that course. And then let's see, there's also going to be an upcoming course by Doug Rosenberg and Tim Wilkins for AI and AI in MBSC. They're calling that AIM training, and it's just AI in MBSC. But it's going to be based off of the book and the methodology that they've put together, essentially using ChatGPT to help you out as a systems engineer, which I think is fantastic. So other courses, of course, STC, the company I work for, we do offer training as well. So if you're looking for a more in-depth training, then absolutely, STC has a course that it lasts about 5 days, where then we go into not only those basics of USM, but then how you can build upon that with modeling and simulation, and then getting into the digital thread aspects of things, where you tie in even mechanical models using Syndea, and that gets a lot more advanced, because then you're reaching out from MBSE at that point into the other disciplines. So there's a lot of other more detailed aspects that can come in from there. But
okay, so this is maybe a good segue into the AI in MBSE domain. I'm quite passionate about AI, or machine learning, right, is what we're really talking about. And actually moving across into how do we adopt this technology. So you said you're maybe co-authoring a book about AI.
Yes, currently I'm a contributor to the book. The authors at this point are Doug Rosenberg and Tim Wilkins. And Tim Wilkins has the publishing company called MBSE for You. He's written the SysMod method and a few other books as well. But yes, I believe that's where a lot of this is headed. And AI can be used in every aspect of architecting a system. You could say, come up with the logical architecture, and then boom, you have a logical architecture, right? So that's one of the very nice things about it. Now, of course, the idea of hallucinations of a model come in, and that's where you need to be very keen on what it's telling you and is it accurate, and that's where engineering rigor is going to come in. So I think it can be very useful to give you a good starting point for a lot of different things, even refining requirements. But then you're always going to want to use that engineering rigor to say, is this right? Let's review this now to make sure that what this model told us is not leading us down some terrible pathway.
Yeah, it's almost a quality check, isn't it? It's, as engineers, we always, write deliverables and then push them up for design review. Actually, now we're just getting another person to the team, right? Where AI is going to be the starting drafter. We then review that quality, and then that gets pushed up the design review type thing, isn't it?
Exactly. I think that's 100% going to be the approach. Is let's see what we can get out of this model for next to nothing, right? And then go from there, and let's build on that. And you can build on that very quickly. So it's absolutely valuable.
Yeah, very powerful. Okay, well, on that aspect, so what makes a good team, a good modeling team, a good architecting team? We're going to get AI soon. So what's that look like now? What does a good team look like now? What does a good team look like in the future?
A good team, well, I do think that AI will be on the team, for one thing. And then, people who are more experienced, you obviously want to have someone who's experienced in methodology aspects, in tool aspects, and that's going to really help make you a lot more efficient. If anyone gets hung up on things, if anyone gets stuck, you can always reach out to one of those more experienced people, and then that'll help you accelerate that timeline quite a bit. But then, of course, you do want to have some of the junior people on the team as well, because they are eager to learn. They're eager to get in there and do a lot of the modeling. And as long as they're bouncing ideas off of people who may have a little bit more experience, you're going to have them come up to speed a lot quicker. And you're going to see a model come together nicely. And it's great to have those junior engineers on the team, because they are eager to get in there and do a lot of that work. So I would say a good team looks like, more experienced people mixed with more junior people, and everyone learning together and coming up to speed. But then also, you're wanting to be in constant contact with the stakeholders and the other engineering disciplines to make sure all of those boxes are being checked as you go.
Okay, so we've built a good team. We have a good understanding of what MBSE is and key principles and mistakes. We've built our model. How do we adopt and use the model towards the later half of the V lifecycle?
Yeah, that's a great question. So obviously, you get into doing trade studies when you're selecting real components, and if you're using tools that can do simulations, that can then come into play, because then you're actually using mathematics involved in doing quantitative analysis to say, how can we quantify what makes this a good part or a bad part? And if you can quantify that, then you can use those parts of trade studies, such as objective functions and different types of weighting. And you can put all that together to where your model can tell you what to select for a certain component. And then if you can select a good component and it meets that logical architecture, then you're done. You're ready to go verify that. And if you've paid attention at the beginning of this, you not only have those components in place, but you have a logical architecture that has functions that can be observed and verified. And that's where it comes full circle, because now you can literally use all of those use cases. You can use the functions that you have to then verify that they do those functions. So as long as you're paying attention at the beginning, it makes the work at the end a whole lot easier.
Yeah. And are we capturing that design then in the model? How do we capture that lower level of design?
Right. I believe it's necessary to capture that in the model. And I think there's other opinions out there where people say, let's leave that up to some of these other tools where, of course, you're not doing CAD drawings in a SysML model, but I believe you should do things to the levels that it helps you integrate them together, right? So, for example, I believe you should be going to the pin level of how different connectors will fit together, and have that in your SysML model and your physical architecture, because you can identify more requirements from that are specific to the physical components that you've selected. And some people leave that out. They say, well, let's not model pinouts. Let's only model this high-level connector interface, and we don't care about exactly how it connects together. And if you do that, you're missing an opportunity, I believe. Now, there are other tools that can do those things as well, such as electrical engineering tools, and they can sort those out. But I think there's a check and balance that can be used by systems engineers to say, hey, you said we should connect this to that, but this requires 10 amps, and this is only providing 5 amps, right?
Yeah.
So we have a mismatch here, and it can be a way to check each other to say, hey, we put this together, and now we have these requirements, and it's telling us something valuable, so let's go check that before we go out to do a big test that's going to cost a lot of money.
Yeah, it's almost like a capture method, isn't it, to make sure that everything's been covered and is actually appropriate before we get to the expensive bit of our program, right?
100% correct.
Yeah.
And I've seen that. So I've seen that happen where, one little pinout caused an entire test to fail that cost people $100,000. So, it's one of those things that if you can do it and it's not that expensive to do that in your model, go for it and see if you can glean some new information that could be valuable for the team.
Yeah. And so we're also capturing our verification activities in the model as well, right? And we're linking them to the architecture and then the design down through. How do we then, after that stage where, we're almost moving into the later aspects of implementation and the V&V and transition and all that, how do we start, or how do we keep using the model into those stages so that it just doesn't get parked and kind of put on the sideline once?
Sure. Well, it'll be an iterative process to where even at that stage, you're refining your model that you have to bounce it off of what is true and what is real and what is current. And you'll see that happen even in an operational setting. You can still update probably that logical architecture to say, we've noticed that this isn't quite right and we like it better this other way. So now let's tweak that and keep that alive, like you said, so that it doesn't just become old and stale and no one cares about it anymore. But, it's going to be a concerted effort for people to keep that going. So it's one of those things, does the project have the time, the money, do they care enough to keep that up to date? Is it something that they're wanting to stay up to date? But I think it really just comes down to what do the people involved want to have that model there for? Are they using it because they want to make some type of a digital twin off of that model? So it's really just going to come down to that specific team and how they want to upkeep their model. But
and whether or not, I guess, if the budget for the in-service team is there to sort of maintain it and update it, right? And actually, because that's the thing. We don't want to just abandon the model and put it on the shelf and kind of forget about it, do we? We want to try and use it and maintain it, and potentially use it for future projects if possible, and iterate and recurse, don't we?
Exactly. That's correct.
Yeah. Okay. Well, that's all my questions, Brian.
All right.
Do you have any other tips and tricks that you'd like to share with beginner modelers or beginner architects coming up through?
Always tips and tricks. Yeah. Get in and make mistakes. That's my biggest tip. Don't be afraid to go in and make mistakes, and run simulations. That's also another tip of mine, because I believe you'll run into a lot of things that you didn't know could even happen. And if you run those simulations, you'll learn a lot, because the model will tell you immediately when something doesn't work, right? So if you go in, practice, push that play button. If you have things such as simulation toolkit, you'll see your model come to life. You'll be able to interact with that, and you'll be able to show someone else. You'll say, hey, look, we made this model, and this is what we intend it to behave as. And everyone will say that makes a lot of sense, right? And then they can also pick it apart and go back to the drawing board and say that's not exactly what we wanted. So that's one of my biggest tips is run simulations, make mistakes, do queries, get in there and start making as many mistakes as you can.
Yeah, in the right environment, right? Isn't it? It's like practice in the right environment, and then when it comes to the real thing, you're ready to go, aren't you?
That's right. Yeah.
Yeah.
Absolutely.
Okay. So how can people hear from you, Brian? How can students learn more about what you're doing and follow along on your journey? Do you have any LinkedIn or YouTube channels they can subscribe to?
Oh, absolutely. So yeah, I'm on LinkedIn, Brian Moberley. Also have the YouTube channel MBSE Insights. So feel free to check that out. I have quite a few videos on there that delve into Cameo and other aspects of simulations. So feel free to follow me on there. Otherwise, yeah, I really appreciate your time today, and it's been great talking with you, Connor.
Yeah, it's been great having you on, Brian. It's been a pleasure. I really thank you for all the hard work you put into your channel. Your channel is awesome, actually. I do go there for a refresher on Cameo from time to time. Guilty, but yeah, no, it's really good. So
that's great.
Thanks for joining the show, Brian.
Absolutely, I'll be looking forward to hearing more about how the School of Systems Engineering is going as well. So good luck to all of you guys out there. You're doing excellent work. It's a noble task.
Thank you very much.